fellow scientists. As a scientist, you probably know that our world is comprised of many interactions, each of which we try to describe with particular formulae. But what if we could unify these formulae into one concise equation that could potentially explain every interaction in our universe, everything, from Genesis to the end of time itself? Well, that equation is exactly what we call a theory of everything. In order to have a theory of everything, we need to unite all four fundamental forces that govern our universe: gravity, the strong and weak nuclear force, and the electromagnetic force. Sounds easy, but there's a catch. You see, the underlying ideas of gravity and the three other forces are drastically incompatible. Whereas relativity says that space is a smooth, even sheet of fabric that can bend and distort in the presence of huge masses, resulting in the gravitational pull of nearby masses, quantum mechanics, the rules that govern the actions of subatomic particles, are very much weirder. See, when we shrink more and more and more into the world of particles, the fabric of space becomes disorienting and turbulent. You can't measure the speed and location of a particle simultaneously, and a particle can exist in two places at the same time, and hey, you're a pretty good-looking particle, though. As you can see, the underlying ideas between relativity and quantum mechanics are incredibly different. Luckily, string theory is the best candidate we have so far that can cope with both ideas. As simply as possible, the basic tenet of string theory is that the most fundamental particles are not atoms, or electrons, or even quarks, but rather tiny one-dimensional filaments of energy called strings. So, how does string theory unite the two ideas? First, let's define a dimension. We use dimensions to predict how to move through space. Our world is comprised of 3 dimensions, meaning we only need 3 numbers to locate any particular point. Well, relativity already explains gravity in terms of space, which takes up all 3 of these dimensions. So, where are the other dimensions to explain the other forces in terms of, right? So the mathematics of string theory predicts the existence of 10 spatial dimensions. In the 10th dimension, there is enough room to accommodate all the forces. Contemporarily, string theory is untestable, as we would need to probe such obscenely high energies. We would need an atom smasher the size of the Milky Way, which isn't exactly feasible, but who knows? Maybe one day we'll be able to replicate the conditions close to the Big Bang and finally test string theory once and for all. And I'm super excited for that day, and I hope you are too. Now I am off to the 10th dimension. Maybe I'll see you there.